In the previous videos, we have discussed about NMOS and PMOS, how to implement logic gates between them. So today we will see that what is a CMOS. So CMOS generally called as a complementary MOS, and it is a combination of PMOS and NMOS. So there will be two types of MOSFET, there will be a combination. So let us directly understand this with a simple gate, that is we will implement CMOS inverter. CMOS inverter, we say that NOT gate as well, NOT gate using a CMOS. We will see how it is implemented. So this is nothing but as simple as NMOS and PMOS. The only thing is that there will be two MOSFETs will be there, one is PMOS and one will be NMOS here. Okay. So if I draw the circuit here, so in this case I will just ignore the load MOSFET. So for simplicity of the circuit, in exam also you can ignore that. Okay. So one, there will be a PMOS. So let us do the PMOS first. So this is source for my PMOS. You see the arrow mark is outside, so this is PMOS, and this is your drain, which will be connected in series with another MOSFET, which is a NMOS. So in NMOS this will be the case, this is source, this will be drain. So here drain to drain connection is there, and in the gate they will be given to one input. Okay, so this will be the gate, they will be connected to one. So in this case, this side plus VDD will be given, because this is a PMOS and the source side plus VDD will be given, and this is a NMOS. For the source side it will be connected to ground. Okay. So I will just mention here. So this is your PMOS and this is your NMOS. Remember that the operation of PMOS and NMOS are exactly opposite. So whenever high is given to NMOS, that will behave, means the operation will be exactly opposite. Let us see how the output is taken. So from here the output is taken. So this will be your output from the middle, means common point of the two drains. Now in the first case, when the input is high, so when the input is high, so what will happen? So in this case, the P channel MOSFET Q1, okay, P channel MOSFET, so that is, let us take Q1 and let us take this is as Q2. So input is high, so Q1 will be switched off, right? So why? Because if it is positive voltage is applied here, let's say I apply plus 5 volt, then P channel MOSFET will not work, and which one will work? Your N channel MOSFET will be switched on, because if plus 5 volt is applied here, there will be drain to source current will flow. So in the output, so we will be getting the value here. It is how much value we will be getting? We are getting 0 volt. Why? Because now this path is completed and this is behaving as a grounded, so we will get 0. Next input, if I apply low, okay, low means what? Let us consider low means we will be applying here minus 5 volt for better understanding. So let us take minus 5 volt. So if minus 5 volt is applied, what will happen? This one will be switched on, right? So this Q1 will be switched on because minus 5 volt, it is a PMOS, so it will, the channel will be created, so drain to source current will be there, and this one will be switched off, Q2 will be switched off if negative voltage is applied. In this case, what will happen? So this plus VDD is there, so that VDD will be appearing across this point through the output, and we will be getting the output as 5 volt. Okay. So for the input is high, so what output we are getting? We are getting 0 volt or low. If the input is low, then output we are getting as high or plus 5 volt, right? So this is behaving as a CMOS inverter here. So that is a simple one. In the next one, we will see some complex gates, AND gate and NAND gate using CMOS. So that will also be easy. You just have to remember NMOS. If you remember NMOS, then the other one you can do it easily. So in the next video, we will see that.